Perfect. Can everybody hear me? Great. So first of all, I cannot tell you how relieved I am because I know there are some strikes today with the public transportation, and I was just about getting ready to speak to an empty room. So thanks everybody for making the effort to get here anyway. And my name is Roni Dover, and I'm going to be talking about two topics that I'm a little bit obsessed about, so apologize in advance, which is OpenTelemetry and continuous feedback. And I hope that I'll give you at least some different perspective on why these things, I think, are one of the most important developments that we have today in software engineering. So a little bit about me. I've been a developer for, I guess, over 25 years now. I started developing in Java. I was a J2EE developer. I was a J2ME developer, so I endured a lot. And I think one of my personal tragedies is that I've never quite decided where I fit the most. So I was a developer, and then I kept going into the design and why are we doing this feature. So they said go become a product manager, and then I couldn't stay away from the code. And then engineering started complaining somebody was checking in features in the middle of the night. So they took away my source code credentials, and it took me a lot of time to find positions that allow me to balance all of that. But throughout all of that time, I was really obsessed with development practices. And one of the reasons is that I saw that they were changing, and it was amazingly cool to witness it firsthand. And development practices and coding practices are still changing. So when I got started some 25 years ago, this was our development methodology, basically getting the release out into a CD-ROM and moving it over to the guys across the hall, also known as the QA department. They would review it, they would reject it. There would ensue some very philosophical arguments about what's a bug and what's a feature. And eventually, this was kind of everything I needed to do in order to be involved in software development. And this is how I wrote code yesterday. So yesterday, meaning in the period of time that passed since then, we started owning a lot more of the process, and it's good that we did. So now when you write a feature, there is this whole definition of done concept. So you don't just write a feature, you write a test, you think about how to test it more, performance test, load test, UAT, whatever. Sometimes you even go all the way to how to deploy the feature, and maybe you've added a new microservice, so you need to know Helm files and Terraform or whatnot. So developers are owning more and more of the pipeline. And I thought this was it. I've witnessed kind of the biggest change in kind of my career, and it was great to see it. It was great to see automated tests becoming a thing. But things are changing still. And when we code today, starting to see how it's not quite the same experience. And some of that has to do with how we write code. And writing code has changed. Libraries are much simpler and faster, to say the least. Like working with Spring Boot 3 is nothing like working with J2EE, just to take the Java example. But at the same time, developers are starting to use tools like LLMs and ChatGPT and Copilot and Code Whisper and all of these things that are just making us more productive. In fact, preparing for this session, I had to work with a library that I've never worked with before. It has despicable documentation. So I asked ChatGPT and got kind of the entire documentation about how to run this performance that I was trying to run. Unfortunately, it was all untrue. But eventually, after much arguing with the chat, I was able to convince ChatGPT that it was not true, and it conveniently told me that since 2022, there's a different API for doing things, and I did manage to get it done. But this anecdotal example aside, I can already see how it's transforming how we write code, right? So I was just looking at our code base recently, and I saw this function, and I saw this peculiar comment, and I look closer, and I see this is the prompt I used to generate the below function as a comment. And I thought, wow, that's a first. That's great that this is happening. And I don't know, like, if to believe the hype yet. Like, I don't think we're at that stage where it is that. I think it's the 55% increase that Copilot is claiming in developer productivity, but I think it will get there. So I think writing code is definitely changing, and we're writing code faster. But there's also the read part. So at the same time as we're revolutionizing how we write code, we need to also revolutionize what we understand from the code. So if you think about it like that, and this really reminds me of a company I worked at that were really keen on continuous deployment. And that's great, right? And all they were obsessed about was how can we release faster, release faster, release faster. And at a certain point of time, I was kind of looking at it from the outside in, and kind of, it seemed to me like all we were doing is throwing features over the fence at a higher velocity. Because there was no feedback, there was nothing we would get back. We would just release, 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 release. And then eventually we started getting bug, 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 bug. And then that's where it turned into another process altogether. I call it BDD, and it's not behavior-driven design, it's bug-driven development. And if you've ever experienced that, then you know exactly what I mean. The team scurries around to put out fires because you've released fast and you didn't listen to what your code was doing. And this raises a very important question, which is, what do we actually know about our code? What means do we have to get data about what the code is doing? I've just created this amazing feature, an massive improvement to the queries or to the cache layer or to the background processing or whatnot. What do I know about it, and what means do I have to actually know things about it? And in the spectrum of knowing things about it, we can start by knowing that it's used at all. And this is a true story. A while back, we were working on this meticulously written code. It was a great feature. It was supposed to boost performance across the app. And 3 months later, we found out that it was never used. There was a bad if statement that prevented it from being used. So I go to the developer and I ask him, why didn't you check? And he asked me a question that made me stop in my tracks, and that was, how? How did you expect me to check it? And this is like on the one end, this is like the simplest example, the dumb side of the spectrum, which is it running? But on the other side of the spectrum, there is, how is it running? What is the improvement? Does it improve anything? And the question is also, when do we know it? So this is the development cycle. At what point do you know things about your code? Because if you know it when it's already in production and it's already causing issues, then that's way too late. And the problem is that historically, because the practice of observability and APMs and all of that came from DevOps and IT, we think a lot about the right side of this diagram. We think a lot about how do we analyze production, how do we understand what's going on there, and we don't think nearly enough about what happens before. Now, I want to tell you a story, and one of the things that I really don't believe in is 10x engineers. But I did meet an engineer once that I think was a 10x engineer in potential. And it's very much related to this example. So the story goes like this. At some point, I look at the log output of our application, and I see it spammed with number 30, 40, 50, 60, 40, 30. And I'm noticing that, and I'm trying to understand why am I seeing all of these numbers. So I eventually track it to the code, and I find a developer to introduce this code, and I ask him, why are you just outputting numbers into the output? Are you trying to track down like all of the digits of pi, or is this like a math experience? Why are you doing this? And he told me an interesting story. He said basically, look, I'm working on this change to this background processing job, and I want to know, as I'm adding code, how I'm influencing the overall performance of this function, of this batch. And I know it's dumb, but what I do is I console out, like I print the iteration time in milliseconds, and I know that it's supposed to be anywhere between 20 and 30. So if I see too many 40s and 50s and 60s, then I know I did something wrong. Now this is the absolute example of the best motivation and using the absolute wrong tools for it. But I will tell you something else. He was the only developer in a team of 20 developers who thought of doing something like this. And that meant that he actually cared about what his code is doing, what's going on, what is my change inflicting on the state of the current state of the application. And this, to me, was the essence of why there is something missing here. Because if we had the right tooling, or if he had access to the right tooling, he wouldn't need to do all of that. In fact, many developers might do something much simpler to understand what their changes are doing. And the point is that if you don't do all of that, and you don't have insights about your code, and you didn't check, and you don't know ahead of time that this extra stage that you added to the data processing was causing these delays, then you'll end up troubleshooting at some wee hour of the night, trying to understand exactly when this was introduced, or trying to understand how the code works when it's already an intricate web of current legacy AI-generated lines of code, and you need to untangle it. So let's take a recap. On the one hand, we know that writing code is faster than ever. I really see it. I believe in it. It's happening. On the other end, the other sources of feedback that we have is debugging. Debugging is great. I debug often, but it's manual. It's very reactive, especially if you're debugging an issue. It's kind of disconnected because you're looking at a specific thread at a specific point of time where the breakpoint just paused and you have no idea what happened before, what's going to happen later. And the problem could be happening in a different instance altogether. So it's very limited in scope. And then we have testing, right? Who here writes tests? Okay, awesome. I should kind of have recorded this like 25 years ago because there will be like 2 hands. So that's great. Please write tests. But tests are limited. Why? Because we're testing only the assertions of the test. So if you think about it like that, by the way, who here is using test containers? Perfect, yeah, awesome. So tools like test containers make it possible to test your system, not just unit, but kind of integration or looking at the service with the live behavior of the service or the application. And all your testing is really very limited validation, whereas you've just conducted a scientific experiment, but you're not measuring what is actually happening when you run your test. And as a result, it's very prone to biases. Now, I can't tell you the number of times that I was trying to retrospect an issue, and the developer replied, but the test was passing. The builds were passing, right? And the easier it is to generate tests, the easier it is to have a lot of confidence. Like, it's called like a false sense of confidence, right? You have so many passing tests, it must be correct. But it's not. And because the tests are testing very specific things that you thought about. They're not testing what you did not think about too. If you guys know the example about the plane from World War II, it's exactly that. It's kind of like you're not testing what you didn't think about. And then there is monitoring. And monitoring is about production, and production is way too late. So I went back to the roots, and I dug up this diagram that everybody's familiar with. It's kind of the most overused diagram, I think, in the history of development. I think it's also not true. Development doesn't really look like that. It's kind of like different. But never mind, it's a good model. And as I was looking at that, something seemed absolutely off. And if you look very closely, we have the continuous integration section or line here that's supposed to take our code into production. That's awesome. But there is also a section going in the other direction. It actually says continuous feedback. This is like the first image that pops up when you search for DevOps. And many of the other images have that. And the only tool assigned to continuous feedback is Salesforce for some reason. I did send an inquiry to the person who came up with this diagram. I did not receive a reply. Maybe he's using a plugin of Salesforce that I'm not familiar with. But if you look closely, it's there, right? We're supposed to have a way to get the information back from production into coding. But there are no tools to do it. And I believe that if we do have faster feedback, if we do have these faster feedback loops, then we can actually also release faster. Why? Because it doesn't, you don't need to troubleshoot because you understand more. So you find the issues early, you iterate early, everything is happening much, much earlier. However, as a product manager, which I was at times, I was kind of contributing to this problem because I have to tell you, nobody in the organization cares about feedback. Everybody cares about the next feature. We're very forward-looking as engineering teams. And as a result of that, I was kind of contributing to the problem. So I have yet to see a roadmap where there is kind of like, yeah, let's create the users, create the groups interface, and then, oh yeah, let's collect feedback. It doesn't exist, right? So the problem is that we don't have time to collect feedback. The organization is not going to stop and do it. So how can we get it? And if you think about it, if it's not integrated into the process, if it's not automatic, if it's not continuous, it's probably not going to happen anyway. How do I know? Because we've all been there. We've had it with testing. Testing started as non-continuous. No developer in his right mind would run the tests manually, see all of the reds, and then have to own that and start fixing issues for the next 3 months. And this is a perfect segue to talk about OpenTelemetry. So why is OpenTelemetry so important? Why am I so excited about OpenTelemetry? I will tell you, it's not because it's the most revolutionary technology in the world. It's absolutely not. It's kind of more like an iteration or a merging of what was before. But there is one defining factor that makes OpenTelemetry the absolute most important technology in getting feedback about your code. And that is that everybody agrees on it. And this didn't happen for a while. Developers really like to argue about things. If you don't believe me, talk to some Scala developers. It's in our nature. So all of a sudden, we now have the ability to have, we now have a framework that everybody agrees on that's open, and as a result, we're starting to get a lot of support for it. So a lot of libraries now natively support it. It's kind of out of the box. And as a result, and I'll show now how it looks like with the code, the experience is more like turning something on than starting this big project. I'm going to start collecting metrics. I need to convince other people that we need observability and so on. It's there, and we can take advantage of it. Now, I do want to stress that this is not an OTel 101 lecture or presentation. Why? Because we don't really need one. The support is of such level, especially in Java, that it's very trivial and it's very easy to find how to get started with OpenTelemetry. I will go through the very basics, but this is not a 101. And the other reason this is not a 101, because every observability talk I've been to in the last year or so was about, okay, this is how you get started with OpenTelemetry, this is how you instrument your code, now good luck, because we're out of time. And nobody was saying, what do I actually do with this thing? Okay, fine, I've enabled it. Now what? So this talk is about the now what. If you are interested and you do want a 101, I did compile together a list of resources. This list contains a lot of things like how do I get started and how do I collect information about the code and what tools do I have to process it, and all sorts of things. So if you do want that, I did compile it. It's not that I was lazy and I didn't prepare it. It's just that I want to talk about something else that I think is much more interesting. So, and I'll show this same link at the end of the presentation. So which data do we use? So we have two interesting sources of data. I hope we can cover both. Let's see how we do on time. One is traces and one is metrics. How many people here are familiar with traces? Good, I'm so glad. So I don't need to talk a lot about it. So just in essence, a trace is basically an anatomy of what happened when something was called in your system, which microservices were triggered, which other, database queries were made, which processes happened, and we have this other terminology, which is a span, which describes an activity within a trace. So to take this 1-minute example, if I go to the get owners API in the pet clinic, in the Spring Pet Clinic sample application, I've created some spans. So now I know when it processed the HTTP request, when it checked for permissions, rendered results, and so on. And the beauty is that many of these things come for free because a lot of the libraries that you are using right now already support OpenTelemetry. And this is what a trace looks like. We'll take a deeper look right now. Enabling OpenTelemetry is very simple. There are many ways to do it. If you're using Quarkus, there's an extension. If you're using Spring, you can use micrometer tracing. The simplest way is to use the agent, but I wouldn't recommend it for production. All of that is in the page that I mentioned. I just want to say that to get started, you don't need to change your code. And I think that's the most important thing. So I can go into my code, I can add a few environment variables, and I can get OpenTelemetry going, especially with automatic instrumentation. So before I explain why we're not thinking force dimensionally, let's look at the code. So over here, as soon as I can find my mouse. Oh, here it is. So over here, I opened the Pet Clinic application. I have duly follow the instructions. So without changing any codes, I've added a few environment variables to my run config. You can also, of course, do it in command line. The most important things I want you to notice here is the Java tools options, where I defined the path to the OpenTelemetry agent that I just downloaded to this directory. And then we have to provide the service name. A service name is basically your application name. And that's it. We've just enabled OpenTelemetry, and we can get started. If you're just sending it to one destination, then it will probably work as is with the default ports and everything. If you want to send it to multiple, then you need another entity called a collector. A collector is just a router. It's a container that you raise, you give it configuration where to send the data to, and it does that. And the information is also on the page that I link to. Now let's get to the important things. So for the sake of this example, and a while back I had some time on the plane, I decided to take this very simple pet clinic application and add some functionality to it. So I dislike CRUD applications as a rule because they don't really offer anything that's more tangible. So I decided we need to worry about pet vaccinations. So I created a mock API, an external one where I can get the vaccination status. I created a way to kind of get the information about the pet vaccinations and then update that as a part of creating or adding a new pet into the system. And also updated the views so that when I actually go and check the owner, I can see whether he needs to vaccinate their pets. All in all, very simple. Let me run this. And the first thing you'll notice as I run this is there is this message here that says that it picked up my Java tool options and it's actually instrumenting this code with OpenTelemetry. So great, it's working. And now I forgot to mention, I'm very diligent. I also wrote some tests using test containers. From my perspective as a developer, this code is ready to go now, but I do like to also validate things on my own as I code. So let's see that it works. I do have tests that cover this, but if I go into an individual owner, I can see whether they need a vaccine or not. And if I add a new pet, it seems to respond pretty fast, and it goes and it looks whether it needs a vaccine or not. Perfect. What else do I know about this code? What else can I check about this code before checking it in? Or after checking it in, or when it runs in CI? Any ideas? Yeah? How long it takes, that could be something. But even before performance, yeah, performance is big. Before we go into performance, what do I know about what I just introduced? And the more complex the system, the harder it is to know. Now, thankfully, in this case, I also was using OpenTelemetry. So let's pull this up. And let's take a look at, Let's take a look at what a request looks like. Okay, sorry. So this is what a request looks like. This is a trace. Now, what do you find peculiar about what we're seeing here? Does anything jump to mind just when you look at this trace? Yeah? Anybody? Yeah, we all see it's n+1, right? But did we see it before we checked in the code? Probably not, right? But where was the information? It was here. And I think one of the most frustrating things in the history of my career as a developer, and the reason why I'm missing some hairs is that I've often had this conversation with a developer, and he said, but how could I have known? But the data was there all along. And we went and we looked at the logs, and after the fact, in hindsight, 2020 vision, it's clear what the problem was. So the question is, how do we transform? So we can collect the information, and this is just one example. I was hoping we'll have time for more examples, but I'll show a link to a few more examples maybe later if we don't make it. But there are things that we can find out just by looking at the current observability data that we're not going to see because it's reactive, because it's not continuous. Think about the concept of a dashboard. A dashboard is an amazing concept that I've never used because I always forget to check them. I was visiting a very high-end company that I will not name, and I was talking to their VP of engineering, and he was showing off all of what they're doing with observability, and I have to tell you, I've never seen something as nice. They had large LCD screens with this huge kind of dashboards and trend lines and everything, and I asked him, wow, this is great. You know, you guys are way ahead of the curve. Are your developers using that? And he said, I have to share something with you. I just had a review with one of my developers, and I asked him about it, and he said he just assumed it was a screenshot. So what do we do? Like the problem is that all of the information is there, right? I just showed you, yeah, path to tracing, OTel 101, yes. Get from here to tracing, that's easy. How do we actually make this useful? How do I actually see this as I'm developing? How do we take all of the information from there to here? And to go back to the fourth dimension, this information is critical even before I pushed out my changes. If I want to know about the current issues, who's using this code in runtime, how does this request work? All of this tracing, that's invaluable. Why don't I have access to that all the time? So how do we use it when we develop? So we talked about the OSS tooling. So I just showed you Jaeger. Sorry, I don't have time to show you Grafana in depth, but basically, and remember, this was written for DevOps. This was written for IT. And as a result, if you look at kind of what the dashboard for, let's say, Spring Boot looks like, it looks like this, which is great for production systems. But what can I do with it in dev? And it's biased, right? It was created for different users. It was not created with people who write code in mind. So based on what I showed you right now, you might be thinking, okay, that's a nice science experiment. I can run it and see some information, but it will probably not affect my work so much. Because who will have the persistence to keep looking at the traces and keep checking for these kind of things? And I can show other examples, like maybe we have an open session in view. Awesome, you're going to see the render trace, and then you're going to have to see some queries after that, and then you'll know that you have made an error that you're using Hibernate with open session in view, and you need to fix that. Great. Or maybe you notice that performance just increased, or maybe you notice a new type of error that was being swallowed and nobody was noticing it. That's great, but you're not going to keep checking. So I wanted something different. And my vision was, how can we get to a situation where, yeah, writing code is faster as ever, but instead of just debugging, we can analyze the runtime. We can see what it's telling us. You know, we have these ML technologies that can generate stuff. I guess the same type of AI can be used to analyze stuff. And I don't need me to go study the traces after each change to look for these kind of things that only an expert developer would realize. If I could have that happen automatically by the specific, you know, by AI. Or just algorithms, just math, right? Not everything has to be AI, quote unquote. And then testing, right? We're looking at testing, the perfect experiment, as I just said before. Why are we not looking at what the testing are telling us? And they could tell a really interesting story about the effect of the last code changes. And then taking the information from production or from real-world environments and putting that information in a way that's accessible for me as a developer. So this is the continuous feedback manifesto. How do we create a way to change all that, to provide a different tool for developers to work today? And this is my own personal journey with continuous feedback. Now, a little bit over a year ago, I started a free tool for developers, and I feel comfortable talking about it because it doesn't cost any money, so I'm not selling you anything. And I also don't specifically want to talk about it. I just want to show it as an example of what it could look like. And there are other tools that are commercial, which is why I'm not showing them, by Datadog that has just released one, and I think New Relic, that are trying to do the same thing, but maybe they're getting there as well. But the question is, how do we actually take that information and make it more integrated? So I want to show you one vision. And then I want you to look at that and think about other applications that you could have, or maybe the tools that you're using already have these capabilities, in order not to create shiny dashboards. And this is maybe the #1 misunderstanding about observability. It's not about creating nice dashboards. It's about how can we code more productively and how can we improve our code. So let's take a look at that same example, at that same code. Only this time, I'm going to just install Digma, which is the plugin that I'm working on. And let's search the marketplace. And I'll just install it here. And then of course the Wi-Fi on the on the conference. And then the other thing that I'll take care of while this is running is I'll remove all of that other things because we can kind of do it automatically. So I'll remove the whole Java tool things and all of that. I can also remove the server side, but never mind. And now, let's take a look at that same code and see if we can find something more useful. Something that is practical, that I can actually use when I'm developing. So, I've just initialized it, and now I have indexing. Yes, and now I have the ability to enable observability, so I've just enabled it, so I'm good. I'm going to run the same example and go through the same flows that I went through before. You can see, yeah, it's instrumenting it in the same way. And I'm going to go through the same flow that I went through before, but the more important thing is what I want to notice about my code and what I want to notice without actually having to search manually through the OpenTelemetry data. Now, it wouldn't be possible if I was not able to collect OpenTelemetry data. So let's try to add the new pet. And again, it worked quite well. But now let's see what is actually going on. And this time, I can actually see what is the information being recorded. So let's start with actually the rendering of the view of the new pet. And guess what? There is an n+1 suspected. And that's great. But the point is that I didn't need to go look. It just happened because in the background, somebody was busy looking for me. And if I want to see where that is happening, I can go to that place in the code and actually navigate to where this is happening and see who's affected by it. And guess what? It's 3 endpoints. Now, yeah, I could have gone and looked through the traces and see who, of all of the traces, which endpoints are using specifically that. But this is something that is now something that I can use quite easily, and I can see the actual query, and I can go all the way to see what the trace looks like. Only I've kind of inversed the pyramid, and this is what I'm trying to get to. And it doesn't matter if you use this tool or other tools. We need to inverse the pyramid so that instead of going through lots of observability data, we first find the issues, and then we can go through the relevant data. Otherwise, it won't happen. So this is just one example. I also was working before with ChatGPT, as I was mentioning, on running this using Hyperfoil and trying to get some load testing going. So I can also see the results of that. And guess what? When I was looking at my scripts that were running performance tests, I actually saw that this particular area was scaling badly. And when I looked, I also saw that the root cause was identified. And this is, again, by just analyzing information that's there. I did not invent any data. And it's the validate owner with external service that's causing the issue. There's some synchronized code here. And again, if I want to see exactly why did it decide that bad scaling is happening, I can drill down and get to that level of granularity. So the point is not this tool, okay? The point is, how do I actually take the information and make it more a part of my process? Because if we don't bring that to be kind of a first-class citizen, if it's not about the code, but about the service level and SLAs and SLOs, then developers won't be able to care about it because it will take too many steps, too many cognitive steps in order to understand what this data means. Best slide. Okay, so I'll be happy if you give me your continuous or manual feedback, either on the feedback for this session or also via my details are also included, like my Twitter handle or email. And I'll be happy for any questions. This is, by the way, the barcode that contains the 101 examples about how to enable OpenTelemetry in your project if you want to use that. Great. Yes?
How many different problems can you detect?
It keeps growing, so I'm not really keeping track. I think one of the approaches that I'm thinking about is how can we take as many examples from the trenches. So, like, the model is, what would an expert Java developer be looking for? And this is how we kind of get more and more ideas and examples. I think it is. I should mention what common mistake I see some other tools sometimes make, which is, and this is where we started as well, is they take all of the graphs and they put it in the IDE or they put it next to the code, but that doesn't help because you need to understand, like, 100% CPU utilization, is that good or bad? Who knows, right? It has to do with the use case and other properties so that you can translate it into something actionable. Yeah? Any other questions?
Can I add something?
Yeah?
I was wondering how is it being done with like security-wise and the analyzing part? Is it taking the code to a separate instance of Figma and like data there, or?
This is like locally. So everything is running locally via containers on your machines. Yep. Cool. If there are any other questions, please feel free to reach out. Thanks a lot.